Okay, this video is new mitochondrial theory of aging. There's an old mitochondrial theory of aging by Harman from 1972, and Nick Lane talks about it in his book. This is Nick Lane right here. Here's one of his books, Power, Sex, and Suicide, about mitochondria. Here's the paperback version of it. I listened to the audiobook, the paperback version, watch videos about it. Here's another one of Nick Lane's books called Oxygen. And his other book is Transformers. I'm currently rereading Transformers. Nick Lane's really good on mitochondria because he's interested in the origin of life, and that relates to mitochondria, the origin of eukaryotes. Okay, but why we're talking about this for longevity in humans. So Nick Lane has come to the conclusion that the number one best thing you could do to get humans to live longer would be to reduce the amount of electron leakage and free radical formation within your mitochondria. So we know a lot of things that do that, and we're going to talk about how you could reduce that. As a matter of fact, he says he believes that's the reason why calorie restriction causes people to live longer, because it reduces the amount of electron leakage in your mitochondria. Well, guess what? As soon as you become a low-fat vegan, you're going to eat fewer calories than you would if you were eating the SAD diet, for example. Okay, it'll make you skinny, and you'll eat fewer calories. Okay, now we're going to take a look at T. Colin Campbell. He wrote the masterpiece book, China Study. And he also says in his books that when you eat animal protein, it has an anabolic effect. We know it increases insulin-like growth factor. It increases activity in mTOR. And that creates an anabolic phase in the body to build stuff. Okay, in general, when you eat protein, it's to build stuff. When you eat fat, it's to store as fat. When you eat carbohydrates, it's to burn for energy. And so the point he's making is that animal protein in your diet causes increased blood cholesterol because the liver mobilizes cholesterol to send to the tissues for growth, for example. Okay, so remember that. High animal protein in the diet causes increased blood cholesterol. That's relevant to what we're going to talk about. Okay, here is Walter Kempner. And Walter Kempner, of course, was feeding patients an incredibly low-fat, low-protein diet. His diet was about 4% of calories from protein, and it was about 2, at most 3, depending on the individual patient, 2% of calories from fat. So the other about 94% of calories were from carbohydrate, and his patients did incredibly well. Reversed all his type 2 diabetics. He was able to cure most of his hypertension patients. He had many patients reverse their EKGs for coronary artery disease. He had patients who reversed congestive heart failure. Lots of patients who, lost over 100 pounds. They asked him, you got any patients who ever lost 100 pounds? He goes, yeah, sure, here's 100 of them. Okay, he had incredible results. He saw over 20,000 patients at his clinic. Anyways, the point was a super low protein diet. We're talking less than 5% of calories from protein. That's really in the range of a VLPD. A VLPD is very low protein diets as they define them for kidney failure patients to protect the kidneys with protein restriction. So that would be 0.3 grams per kilogram per day. So an RDA, recommended daily allowance diet, is 0.8 kilograms per day. Okay, Americans are eating like 1 gram per kilogram per day or more. That's a lot of protein. Okay, a low protein diet is 0.6 grams per kilogram per day. Then half that is very low protein diet, 0.3 grams per kilogram per day. Okay, so the point is dramatically low protein diets. He wasn't giving them any supplements that I'm aware of, and the patients did extraordinarily well. Okay, and now that brings us to James Mitchell. James Mitchell made the observation. He was very impressed by the results that Dr. Walter Kempner got with his patients, and he came to the conclusion, gee, everybody knows caloric restriction increases longevity. Well, we could get the same results they found in animals by just protein restriction. And if you can protein restrict, as a matter of fact, all you need to do is methionine restrict, which is an amino acid. And he felt that one of the reasons why low protein diets were so effective at causing weight loss and making the patients healthy was that normally there's some extra amino acids around that the liver will run through gluconeogenesis, convert into, you deaminate them, take the amino group off them, and you can convert them into glucose. That's gluconeogenesis, the making of new glucose in the liver. And what he said was there's a shortage of amino acids around when a person eats a very low protein diet. And because of that, the liver will take triglycerides from the adipose tissue, the fat tissue, and it'll take the glycerol, the 3-carbon backbone, like a propane triol. So there's 3 carbons attached to hydroxyl groups. It'll take that, send those to the liver, and that's like half of glucose, and convert those into glucose for gluconeogenesis. And then it'll take the fatty acids, which it has no use for, and just have those burned, like in brown adipose tissue, burn them for heat. Okay, so just send them to the mitochondria and just burn them for heat. You can uncouple, you don't need to even make ATP, just burn them for heat. If you uncouple the inner mitochondrial membrane such that the electrons are allowed to leak back in, You can still run electrons down the electron transport, but you don't produce free radicals, okay? And it's a way to generate heat. The point is it makes people skinny, okay? It's good to be skinny. Skinny is better than being fat. Okay, here's just a real quick look at a mitochondria. You know, there's an inner membrane. That's where electron transport is located, the green. There's an outer membrane, the black. There's intermembranous space between those two where the protons are pumped. The yellow stuff is the matrix. Okay, so when you get something inhibiting electron well, even normally, some electrons will leak. They'll just fall off in this range anywhere from complex 1 through coenzyme Q to complex 3, and they'll drop onto oxygen, form superoxides, okay? That's electron leakage in the mitochondrial membrane. And in small amounts, it's normal. We've got enzymes like SOD, superoxide dismutase, that's going to help convert them into water and oxygen. You're going to have other enzymes in there that help catalase, glutathione peroxidase. Okay, but the point is we can routinely handle small amounts of that. But when there's problems with this electron transport, like we're going to show some of them, and you get an excessive amount of this, it overwhelms superoxide dismutase, and you start producing free radicals that can damage this inner mitochondrial membrane and even, kill the mitochondria. So we're going to talk about all that. Okay, here's just a little more detail. The electrons are passed down till they get to the ultimate electron acceptor, oxygen, and then that's converted into water. Okay, the protons, H+, are the hydrogen nucleus that's just pumped into the intermembranous space. Later on, this gradient of hydrogens is harvested by bringing it back through the ATP synthase, which spins like a water wheel. And it's really a rotary turbine nanomotor to generate ATP, adenosine triphosphate. ADP is adenosine diphosphate, 2 phosphates. Adenosine triphosphate is 3 phosphates. And it's a real high energy bond, the last phosphate, so you can do a lot of work with it in the cell. It helps make a lot of reactions run. So here's the problem with fat, especially sat fat will inhibit electron transport in this region, and that will lead you to spill more electrons down into the matrix. Okay, so that's bad. So this is one of the reasons why it's bad to eat fat. Sat fat in particular for this component of insulin resistance, but all the fats eventually make the person fat. Then when they're obese, their fat cells start spilling over, leaking fat into the blood. So they all end up being bad. They're all atherogenic. They're all obesogenic. Okay, and the omega-6s cause all kinds of problems through lipid peroxidation as well, including the inhibition of intermitochondrial membrane. So here's just a little more detail. Superoxide dismutase converts the superoxides to hydrogen peroxide, then catalase and glutathione peroxide is converted to the harmless water. But in the setting of free iron, which a lot of people have, excessive free iron, you can run the Fenton reaction. Fe for ferrous, like iron, Fe for Fenton, and that can produce hydroxyl radicals. Those can undergo lipid peroxidation of the intermitochondrial membrane and damage it, okay? If you got excessive, well, I'm not going to get into the brain stuff, okay? But now, I've told you this before, I went and started looking up mitochondrial inhibitors. I went through all my college, biochemistry textbooks, like the old Stryer, the old Stanford stuff, nothing about mitochondrial inhibitors. And I went through the Leninger, and I went through all the other mitochondrial textbooks, through the nutrition biochemistry books. Nothing at all. Not a word about mitochondrial inhibitors, nothing useful. Okay, so I started going through the literature. I knew there had to be more because I knew that sat fat inhibited it, and there had to be more. So I found tons. I quickly found 10, 20, 30, 40, then 50, 60, and 70 mitochondrial inhibitors, and they're real common things. Okay, why does this matter? Because these things are going to cause electron leakage. Fluoride in your drinking water is a mitochondrial inhibitor. Aluminum is toxic to mitochondria, okay? Lead is toxic to mitochondria. Mercury is toxic to mitochondria. Chromium is toxic to mitochondria. Cadmium is toxic to mitochondria. Glyphosate sprayed on soy is toxic to mitochondria. Atrazine sprayed on corn, toxic to mitochondria. Hydroxynonenal from omega-6 cooking oil is toxic to mitochondria. Okay, some of these beta blockers, common cardiac medicine for hypertension, can be toxic to the mitochondria. Tylenol, metformin for diabetes, statins, okay, for lowering cholesterol. Mold inhibitors like these antifungals put into all the processed food, all the fast food, so it doesn't grow mold on it, and put into lots of personal care products. Bad. Selective serotonin reuptake inhibitors, tricyclic antidepressants, antipsychotics like Haldol, okay? Lots of common medicines are mitochondrial inhibitors, and some of these are causing electron leak in excessive amounts. So I doubt they're going to help you to age well. A lot of these antibiotics, fluoroquinolones, penicillin beta-lactams, aminoglycosides, tetracyclines, okay? Arsenic does it also. Oh, I'll just give you one quick story too. A lot of times I like to wear my jacket, even though it's really hot outside. It's in the 80s and 90s even. the last couple of weeks. So, but people give me a hard time. I was like, I don't care if I sweat. Your kidneys, your sweat glands are like little kidneys, and they excrete these heavy metals like, they'll excrete arsenic and mercury and aluminum and lead. So anyways, that's good. So the point I'm making is people are exposing themselves very often to 4, 5, 10, even 15 of these mitochondrial inhibitors, and that's likely to cause increased electron leakage. So here, I'm going to put the theory all into perspective now. That was just sort of the backdrop. Now here's the real theory, and here's what's new and what's good. Okay, so a combination of what we've learned from the past from all these pioneer experts like Otto Warburg, who showed that hypoxia, lack of oxygen, damages mitochondria. We talked about Colin Campbell, animal proteins anabolic, increasing blood cholesterol, blood lipids. James Mitchell on losing the weight by eating low-protein diets. Okay, so why does this matter and why am I bringing this all up? What puts this all together? Well, Nick Lane's observation from evolutionary biology is, well, gee, birds are living a lot longer than mammals of the same size. A wild rat's only going to live about 2 years, maybe 3 years domesticated in captivity. Birds live much longer. Pigeons routinely look, with pigeons like a flying rat, they live 20 years in captivity, 10 times longer than the rat does. Parrots can live up to 100 years. Albatross can live even as long as 150. I know they don't always get that, but they live a long time, and it depends what you read. But Nick Lane posted these numbers, and I looked them up, and this is a little bit better than usual, but they still can live an extraordinarily long amount of time, birds. And also, you know who lives a long time is a bat. So a bat is almost like a flying rat. They live 20 to 30 years, so 10 times as long as the rats. Okay, so that's pretty extraordinary. Nick Lane says it's because when you fly, it takes such extraordinary high amounts of energy that the birds have tons of extra mitochondria. And so when they're at rest, their mitochondrial systems can very easily handle the small amount of spontaneous electron leakage that occurs. So he says it's good to have a lot of extra mitochondria. Well, how can you get extra mitochondria if you're a person? Exercise. But you don't want to overdo it, because if you overdo the exercise, I personally don't think all this triathlon stuff and marathon stuff is a good idea. I think it's a little crazy, just to let you know. When I was a young guy, I used to be in wrestling practice for a couple hours, and we handled that pretty well. But that's not the same as, running 20 miles a day and then running 26 miles like Phidippides, the ancient Greek guy. He died afterwards, okay? These marathon runners and these triathletes, they got increased incidence of atrial fibrillation and other health problems, okay? And I've seen some patients with those problems. So I think it's reasonable, running a 10K race at the most would be my opinion. I ran cross country many years ago. Anyways, I like to, just run a couple miles, get some exercise if you want. Walking's all you really need to do. I think it's good to do some high intensity interval training because that's going to generate a whole bunch of mitochondria. I like to walk upstairs. I told you I do the bear walk with weights. I'll put 20 pounds, sometimes 25 pounds of books in my backpack, and I'll walk up 10 flights of stairs. So I get some muscle exercise from carrying the weight, plus I get the aerobic exercise. And I know I breathe harder from doing that than I do from walking fast on a treadmill for an hour. So you can't fake the stairs. Like I've done a lot of isometric exercise, but you can sometimes kind of half-ass an isometric exercise. You can't half-ass walking up the stairs with 25 pounds of books in your backpack. Okay, you can't bullshit that. All right. So, anyways, it's good to do some high-intensity interval training, so you got a lot of mitochondria, and they can handle the free radical, the spontaneous free radical leak that's normal. Okay. Let's see what else. Nick Lane says the number one best things humans could do to age better and be healthier would be to reduce electron leakage in their mitochondria. And how are you going to do that? Avoid eating high-fat meals. And I would also say avoid eating animal protein because that's going to push you down that path of elevated blood cholesterol and whatnot. Nick Lane, like I said calorie restriction probably causes increased longevity because it decreases electron leak and free radicals in the mitochondria. And I would, like I said, we know SAT-FAT blocks intermitochondrial membrane electron transport from the Michael Brownlee paper, Diabetes Unifying Theory of Complications. So that's the reason why you want to avoid SAT-FAT, which means avoid animal foods. Animal foods are loaded. SAT-FAT's basically animal fat, coconut fat. Excessive dietary sodium is a milder cause of insulin resistance. For other reasons, you can't get the insulin into the muscle capillaries, skeletal muscle capillaries postprandial. Okay. I've also noticed that electron inhibitors will often cause increased electron leak. Well, guess what? We just talked about all of them. There's tons of them. And you avoid them by being a minimalist and avoiding processed food. And avoiding medications if you can. We learned about Warburg saying hypoxia causes mitochondrial injury and electron leak, free radicals. So what do? You avoid fat meals. They cause tissue hypoxia, okay? And sodium contributes to making that worse. We learned from Jay Mitchell that low protein diets help us to lose weight. Well, that's good. And they help also to uncouple some of the mitochondria to burn energy for heat, which also lowers electron leakage, okay? Because it keeps the electrons flowing rather than being stuck and having to go backwards and dropping off the electron transport chain. Okay, we learned from T. Cole and Campbell. I talked about the animal protein stuff, raising blood cholesterol. We know stress, sleep deprivation, caffeine, they all raise blood lipids. Caffeine does the same thing as sleep and stress. Increases catecholamines and cortisol, which increases blood lipids and causes insulin resistance, more diabetes. We know that religion lowers your stress. All the people in the major religions are much healthier than the non-religious peoples. I see atheists do all kinds of stupid stuff, commit suicide, become drug addicts, alcoholics. Having a sense of purpose in your life makes you more resilient. Getting along with people. Okay, and what else can we do to get the best out? You know the diet. Low fat, low protein, low sodium, 100% vegan, 100% organic, single ingredient foods only, no oil, alcohol, tobacco, MJ, none of that nonsense. I like avoiding all powder foods because they tend to put heavy metals in them. So anyways, this was the point. I think that Nick Lane is onto something. Can I guarantee this? No, but I can tell you theoretically it makes a ton of sense, and I don't see any downside to it. And it sort of combines knowledge from a bunch of different areas. It's really sort of a modified, updated version of the old mitochondrial aging theory. The problem with the old aging mitochondrial, well, we're not even going to get into it, but the old aging mitochondrial theory was way too simplistic, okay? This is more practical from all the knowledge we've accumulated, and what is it? It's about 50 years. It's over 50 years since the 1972 mitochondrial aging theory. So anyways, I hope you found that helpful. I've got other lectures on mitochondria. If you look around for Nick Lane, you'll find he's got a bunch of free lectures on YouTube about mitochondria. I think his lecture called Thoughts on Aging is good. I think his other lecture called What is a Feeling? He talks about the mitochondrial component of your emotions. I think those are good videos of his. So anyways, hope you found that helpful.